Hey friends, welcome back to Student Science Technology. I am Pavan. Our today's project is going to be on building a soundometer. We are going to use sound sensor with Arduino Uno to calculate the frequency of the sound it receives from its surroundings. Basically, a sound sensor is defined as the module which detects sound around it with its intensity and converts it into electrical signals. A sound sensor can be of two types: LM398 sound sensor, LM393 sound sensor. A sound sensor also has a built-in capacitive microphone and an amplifier that is highly sensitive to sound. So let's start the project. Now that you know about the sound sensor, let's discuss its pins. It consists of 3 pins: VCC, ground and out. VCC pin is the power pin of the sound sensor. It should be connected to the 5 volt of Arduino. Ground pin is the negative pin of the sound sensor. It should be connected to the ground of Arduino Uno. Then it's the out pin. This sound sensor is a digital sound sensor. So this out pin must be connected to some digital pin of Arduino. I am going to use digital pin 7. Let's start wiring it. Now I have connected all the pins to its respective connectors. Now let's start programming. So friends, now I'm going to explain you the code. The first line over here defines Arduino that the sound sensor is connected to digital pin 7 of Arduino Uno. Then we are going to calculate the value of the sound sensor using time. So this millis current is used for that. We have two more variables over here, millis last and millis elapsed. These two variables are used to display the value of the sound sensor. We need a storage point to store all the value from the sound sensor, right? So this variable sample buffer value. All the values from the sound sensor are stored in this. Void setup is as same as before, serial.begin 9600. 9600 is the baud rate, and this command begins the serial monitor as well as the serial plotter. Let's go for the void loop. Void loop, first two lines has some calculations. Then comes if digital read out pin, which is a sound sensor, gives low, which means it can receive sound values. The sample buffer value, the values we receive from the sound sensor, will be increased if millis elapsed is greater than sample time. Serial.println sample buffer value. In this condition, the sample buffer value, which is the value we receive from sound sensor, will be printed on serial monitor or the serial plotter. Then we have delayed for 40 seconds. This is done because the Arduino runs very fast. So it is even difficult to read the numbers in the serial monitor, but it won't affect the serial plotter. Right, so let's test it. I've already uploaded the code. Now I'll connect it to my laptop. Let's test it. Now that I have connected to my laptop, you can see that the LED starts blinking. I'm opening my serial plotter. As you can see, when I talk, there is a difference in this graph. Because of the sound sensor receiving my voice and this code, there is a graph shown on the serial plotter. Hello, welcome to Student Science Technology. I am Pavan. So friends, that was all for today. I hope you enjoyed the video. We actually even have a bad news to share with you. From next week onwards, we can get new videos to you only on weekends due to some problems. I hope you understand. Thank you. Have a nice day.